Deep within our planet, a silent and ancient process is at work. It is a story of immense pressure, unimaginable heat, and the slow, inexorable movement of rock. At the heart of this story is gold, a metal that doesn't simply appear but travels. Gold journeys through the Earth's crust, following hidden pathways carved by the planet's folds, faults, and fractures. Superheated, mineral-rich water is forced upward, seeking out cracks and weaknesses in the rock. These structures act as both guides and traps, sometimes providing a clear road, other times creating a dead end where gold finally drops out of solution. Understanding this hidden architecture is the key to unlocking the Earth's treasures. For the prospector or geologist, reading these signs transforms the landscape into a map of potential. A simple bend or crack becomes a clue, a possible trap or highway for gold. We begin our journey by following these secret pathways, learning to spot the clues left by ancient processes. The search for gold is not just a hunt for metal, but a quest to understand the forces that have shaped our planet. Imagine pushing a stack of blankets together. They buckle into arches and troughs. This is what happens to rock layers under pressure, forming folds, anticlines, arches, and synclines, troughs. These folds concentrate gold by creating zones where pressure and temperature change, forcing gold out of solution. The crest of an anticline, stretched and fractured, becomes a perfect funnel for gold-bearing fluids. Here, gold precipitates out, forming rich veins along the arch. Synclines can also trap gold, especially if porous layers are sealed by impermeable rock, creating reservoirs. On the surface, these folds appear as curved layers in cliffs or road cuttings. Finding the hinge of an anticline is a prime goal for prospectors. It's where nature's forces create ideal traps. By understanding these bends, we see how the Earth gathers its wealth with elegant simplicity. The Earth's crust is a shifting mosaic of tectonic plates, creating immense stress and breaking rock into faults. Faults are not just cracks, they're dynamic superhighways for hydrothermal fluids carrying gold. Shattered rock along faults, called breccia, forms permeable channels for these fluids. As fluids move through, they cool and react, causing gold to cement the fragments together. Some faults pull rocks apart, creating voids, prime spots for gold to drop out of solution. Thrust faults can trap fluids beneath impermeable layers, pooling gold-rich water. On the surface, faults appear as valleys, springs, or changes in rock type. Prospectors look for fault breccia or quartz veins as signs of these hidden highways. Recognizing these features allows us to trace the gold's journey from deep within the Earth. By following these clues, we uncover the routes that brought gold closer to the surface. Faults are the main arteries in the Earth's plumbing system for gold. The Earth rarely lays its secrets flat. Rock layers are often tilted or dipped by tectonic forces. The dip acts like an arrow, pointing to where gold-hosting rocks might be found below the surface. Hydrothermal fluids follow these tilted layers, much like water down a slanted roof. By measuring the dip at the surface, geologists can predict where gold-bearing layers lie at depth. This transforms gold hunting from guesswork into science. Where dipping beds intersect faults, fluids may pool and deposit gold, a natural hotspot. Geologists use compass clinometers to measure dip and strike, building a 3D map of underground structures. Mapping these orientations reveals the hidden geometry of the land. The intersection of dipping beds and faults is a prime target for gold. Reading these tilted clues guides the search to the most promising locations. Some zones in the Earth's crust are so stressed that rock stretches and deforms, creating shear zones. These ductile fault zones are highly favorable for gold deposition. Shearing aligns minerals into bands, making the rock permeable and reactive, a perfect host for gold. Ribbon quartz, formed as veins are stretched, is a key indicator of gold-rich shear zones. Gold often appears as fine particles within these quartz ribbons or along dark seams. Shear zones act as long-lasting plumbing, reactivated by tectonic stresses and enriched by multiple fluid pulses. The intense deformation pumps fluids through, leaching gold from surrounding rock and concentrating it. Identifying shear zones involves spotting stretched rocks, ribbon quartz, and aligned minerals. These corridors can be miles wide and long, representing immense geological power. Within these transformed rocks, the perfect conditions for gold are created. Folds, faults, dipping beds and shear zones form a complex, interconnected network underground. The richest gold deposits are found where these pathways intersect, structurally controlled ore bodies. For example, in Western Australia, a prospector might follow a shear zone intersected by anticline folds. The intersection of a sheared highway and a fractured fold crest creates a natural convergence point. Here, fluid flow changes, pressure drops, and gold precipitates in concentrated ore chutes. These intersections act like dams, causing gold to drop out in abundance. Understanding this structural web is the master key to large-scale gold deposits. A fault alone is a highway, a fold alone is a trap. But where they intersect, the Earth creates geological sweet spots, true bonanzas. It's in these complex locations that gold is concentrated from a vast plumbing system. The quest for gold begins with knowledge, not a pickaxe. Modern prospectors study geological maps to identify promising intersections of structures. In the field, they look for physical evidence, outcrops, quartz rubble, and structural clues. Tools like GPS and compass clinometers help confirm the orientation of rocks. Technology aids the search. Geophysical surveys reveal hidden structures, and geochemical sampling detects traces of gold. These clues guide prospectors to the source. Ultimately, the moment of discovery comes when a rock is broken open and inspected for gold. Here, theory meets reality. The Earth's hidden pathways become tangible. The search is a blend of science, observation, and hands-on exploration. The story of gold is woven into the story of our planet, a tale of creation, movement, and concentration. We've explored folds, faults, dipping beds, and shear zones, each a chapter in the Earth's grand puzzle. This structural web is a masterpiece of natural engineering, transporting and depositing gold over millions of years. Faults are the pipes, folds the traps, dipping layers the feeders, and their intersections the treasure vaults. Understanding this interplay turns searching for gold into scientific exploration. The key is to think in 3 dimensions, visualizing the structures beneath our feet. Start with maps, look for evidence on the ground, and follow the pathways to their intersections. The Earth leaves clues for those patient and knowledgeable enough to see them. The greatest discovery is not just gold, but the realization that the planet's story is written in stone. The true treasure is understanding the Earth's enduring secret, hidden in its very structure. Very